Hello everyone! In this video we're going to learn a quick method or a shortcut to solve some quadratic equations. But now, before we learn the method, here we have a quadratic equation. If we factorize this quadratic as we learned in the previous video, we would have x plus 2 multiplied by 3x plus 2 equals 0. And if we solve this equation, we would say either x plus 2 is 0, then x would be negative 2, or the second one here is 0. So in this case, if we solve for x would be negative 2 divided by 3. So here, if we solve this quadratic equation by the factorization method, or by the quadratic formula, we would have these two solutions, negative 2 and negative 2 divided by 3. But now, we will solve this equation using the shortcut method. The method is this. First, we multiply this number here, the coefficient of x squared, we move it and multiply it by the constant term, which is here 4. And 3 by 4 is equal to 12. Then we write the equation like this: x squared plus 8x as it is, plus here 4 by 3, 12, equals 0. So as we see here, we have a different and simpler quadratic equation that's easily factorized. Here, if we factorize it, we would have x and x. Now, we need two numbers add up to 8 and multiply to 12. They are plus 2 and 6. So, if we solve this quadratic here, we would say either x plus 2 equals 0, then x will be negative 2, and from this, the solution would be negative 6. These are the two solutions to this simpler quadratic, not to the original equation. And now, to get the solutions to the original equation, we just divide these two answers by this number here that we multiplied by 4. We divide these by the coefficient of x squared. So here, if we divide by 3 for both, we will have the two solutions. Here we have negative 2 over 3, and here we have negative 6 divided by 3, which is negative 2. So as we see here again, the two solutions are negative 2 and negative 2 over 3, as we got here. Negative 2 over 3 and negative 2, they are the solutions to this original quadratic. Let's now have another example. Here again, we will multiply 2 by negative 7, which will be negative 14. And we write x squared plus 13x minus 14 equals 0. This quadratic can be factorized into x plus 14 and x minus 1, because 14 and negative 1 add up to 13 and multiply to negative 14. So as we see, the two solutions are either negative 14 or positive 1. These are the two solutions to this simpler quadratic only. To get the solutions to the original equation, we just divide by this number 2, the coefficient of x squared. If we divide here by 2 and here by 2, then the solution here is negative 7, and here it's half. So negative 7 and half are the solutions to this original quadratic. The last example here, again, we multiply 6 by negative 2. We will have negative 12. So x squared minus x minus 12 equals 0. We can factorize it. Here, we need two numbers add up to -1, because here we have -1, and multiply to -12. The two numbers are -4 and +3. So the two solutions here, we would say either x minus 4 is 0, so x will be 4, and the other one, the solution will be -3. Now, to get the solutions to the original equation here, we divide by this number the coefficient of x squared. So we divide here by 6 and here by 6. The first solution here is 2 divided by 3 when simplified. And here, if we simplify -3 over 6, we would have -½ So these are the two solutions to this original equation. Now, I would like to note that this method works only for the quadratic equations that have integer solutions or fractional number solutions. Fractions like 2 over 3, -½ half, or -7, or any whole number. And it doesn't work if the solutions are radicals or square roots, like for example 5 plus or minus root of 17, let's say, or any other radical. And in that case, we cannot do, or we cannot solve even the quadratic by factorization. Then we can do it using the quadratic formula in that case.